The home connection, multiplication models, and more on page 77. Question number 3. Ask students to use an area model divided into two regions to show 13 times 34. This partial product finder app is one way that we can do that. The problem is 13 times 34, so up here on this top left boxes, I'm going to put in my two factors, 13 times 34. And if I click on make, it will make a large array of 13 times 34 with those two dimensions there. Now, in order to solve that in two regions, I can divide either one of those factors into two different parts. So the easiest thing to do is to divide my factor of 13 into 10 and 3. And I can see that I have one region here, which is 3 times 34, and one region on the bottom that shows 10 times 34. And we can see on the bottom even that what is highlighted in the array is highlighted in the equation. 3 times 34 plus 10 times 34 equals 13 times 34. That could be what that model looks like using two regions. If I click this button over here where it says answer, it will then show me that 3 times 34 is 102 plus 10 times 34 is 340 equals 442. Of course, there are other ways that we could divide this into two regions. I could set that back at my original starting point. I could divide up my 34 into 30 and 4, base it off place value. And then I have two regions again, 13 times 30 plus 13 times 4 equals altogether 13 times 34. And if I click on that answer, that's going to give me that same total 442, with each of these being the partial products, hence the name partial product finder. For question 2, it asks to use an area model divided into 4 regions, and that problem is 14 times 27. Click on make, makes the large array. So again, the easiest thing to do is to break it apart by place value. So I divide that 14 into 4 ones and 1 10. And 1 10 on the top and 4 ones on the bottom. I also want to break apart my 27 or decompose my 27 by its place value of 2 10s, which is 20, and 7 ones. So I slide that over there. So now I have 4 regions, which is what this question asks. So again, we can see all the partial products on the bottom. There's 10 times 20 plus 10 times 7 plus 4 times 20 plus 4 times 7. It's the same as 14 times 27. This is a lot more manageable for students to solve. 10 times 20, we should be able to know is 200 at this point. Anything times 10 is pretty simple for students to do. 10 times 7 is 70. We have 4 times 20 or 4 times 2 10s, 80, and 4 times 7 is 28. If I click on my answer button, I see all those same partial products that I came up with. I would add those all up to get my final product of 378.